Welcome to this explainer. We are about to embark on an absolutely epic geological descent. Today, we're tracing the staggering 60 million year journey of oil and natural gas formation. We're going to go deep underground to look at the extreme conditions, the crushing pressures, and the soaring temperatures required to create the fossil fuels that literally power our modern world. Okay, let's dive right into this. 0.1%. Crazy, right? But this tiny, tiny fraction is where the entire story of oil actually begins. You see, when living organisms die, plants, animals, you name it, most of them are naturally recycled. They're eaten by predators, scavengers, or bacteria, or they just simply oxidize in the air and ambient water, breaking down into water and carbon dioxide. But just a tiny proportion, about 0.1% of this organic matter, manages to escape that fate to begin this massive journey.
Section 1. The Ancient Organic Origins, where it all begins.
So how does this surviving 0.1% actually initiate the sedimentary process? Well, this organic matter is transported by water and slowly sinks down to these really poorly oxygenated environments at the bottom of the sea, safely tucked away from disruptive tidal currents. Down there, it mixes with inorganic materials, things like clay particles, very fine sand, and countless dead microscopic marine plankton. Over time, anaerobic bacteria, the kind that absolutely thrive in environments without oxygen, they get to work. They transform this entire mixture into a dark, pretty foul-smelling mud.
Now, you might be thinking any old mud can become oil, but no way. To become what geologists call source rock, this mud needs to harden and contain at least 1 to 2% organic matter. That percentage might seem low, but it is incredibly difficult to achieve in nature. And here's why. It requires highly specific geographical conditions. First, you need a hot climate to trigger massive plankton growth. Second, you need to be located near the mouth of a major river to sweep in abundant plant debris. And third, crucially, there has to be a lack of nearby mountains. If there were mountains, they dump way too much inorganic sediment into the basin and totally dilute the organic material.
Section 2. Sinking into source rock. Forming source rock.
Okay, so to understand how we actually get deep underground, we got to look at a spatial process called subsidence. Subsidence is basically the gradual sinking of a sedimentary basin. What happens is that over millions of years, new sediment continuously piles on top of our source rock. The sheer weight of all this accumulating material very, very slowly pushes the source rock further and further down into the Earth's crust. Let's map this out on a timeline. Starting at year 0, when the organic matter first settles, it takes about 1 million years for the basin to sink an average of just 50 meters. Think about how agonizingly slow that is. At just 50 meters every million years, it takes a staggering 60 million years for those dead plants and animals to finally reach the depths required to become liquid hydrocarbons. This massive, slow-motion timeframe is the backbone of the entire process.
Section 3. Kerogen in the pressure cooker. Kerogen formation. As we go down, the physical forces just relentlessly escalate. For literally every 100 meters we drop, the pressure increases by an average of 25 bar. By the time we hit just 1 kilometer underground, the temperature is already at 50 degrees Celsius, and the rock is being squeezed by 250 bar of pressure. Down at 2 kilometers, it's 100 degrees Celsius and 500 bar. We have entered a literal underground pressure cooker.
Under all this extreme pressure and heat, the organic matter undergoes this massive chemical change. The nitrogen, sulfur, and phosphorus atoms are gradually stripped completely away. What's left behind is this intermediate material known as kerogen. It's a phase made up of water, carbon dioxide, carbon, and hydrogen. And this kerogen phase is an absolutely essential stepping stone before we can get anywhere near usable fuel.
Section 4. The oil and gas windows. The sweet spot.
All right, this brings us to a really fascinating geological concept. Between 2,000 and 3,800 meters deep, we enter what's called the oil window. This is the precise sweet spot where kerogen actually cracks and turns into liquid oil. But if that source rock keeps sinking due to subsidence, dropping between 3,800 and 5,000 meters, the production of liquid hydrocarbons peaks. That deeper, extreme environment causes those liquids to become increasingly lighter until they gradually turn into methane gas, the lightest hydrocarbon. This hotter, deeper zone is appropriately known as the gas window. But depth and temperature aren't the only deciding factors here. What's really brilliant is how the original dead matter actually dictates the final product. The proportion of liquid oil versus gas depends heavily on the type of source rock. If the ancient debris was mostly of animal origin, it produces predominantly oil. However, if the debris was mainly plant-based, that exact same source rock will primarily generate gas. Now, this epic descent can't just continue forever, right? There is a definitive, dramatic limit to this whole process. If the sedimentary basin sinks too far, dropping below 8 to 10 kilometers deep, we enter what is known as the destruction zone. Down here, the temperatures are so impossibly high that they completely destroy all hydrocarbons. The very fuels that took tens of millions of years to painstakingly form are simply annihilated by the Earth's intense internal heat.
Section 5. A non-renewable reality. A harsh reality? So, when we look at these immense geological forces, the highly specific geographical conditions required, and that incredibly slow subsidence rate of 50 meters per million years, well, the concept of a non-renewable resource suddenly takes on a whole new weight, doesn't it? I want to leave you with a final thought to chew on. Every time you use energy, are you considering the 60 million years it took the Earth to create that drop of fuel? It's a staggering thought, and I hope this explainer has given you a newfound awe for the epic journey happening